The Avro Shackleton was a British long-range maritime patrol aircraft used by the Royal Air Force and the South African Air Force. It was developed by Avro from the Avro Lincoln bomber, itself being a development of the famous wartime Avro Lancaster bomber. It was replaced by Nimrod maritime patrol aircraft in the 1970s. The aircraft was also adapted for airborne early warning roles within the RAF, replaced by the Boeing E-3 Sentry in 1990. The type is named after the polar explorer Sir Ernest Shackleton. Entering service with the RAF in 1951, the Shackleton was used primarily in the anti-submarine warfare and maritime patrol aircraft roles. It also became used as a search and rescue platform and for performing several other secondary roles such as being a troop transport. In later life, a small number of the RAF's Shackletons were subsequently adapted for airborne early warning duties, performing in this capacity until the type's retirement in 1991. The Shackleton was also procured by South Africa, and was operated by the SAAF between 1957 and 1984. Development. Origins. The Battle of the Atlantic was a crucial element of the Second World War, in which Britain sought to protect its shipping from the German U-boat threat. The development of increasingly capable diesel-electric submarines had been rapid, in particular the elimination of oxygen restrictions that had previously limited underwater endurance via the use of a snorkel to eliminate the need for surfacing when recharging a vessel's batteries. Aircraft that had once been highly effective submarine killers had very quickly become incapable in the face of these advances. In addition, Lend-leased aircraft such as the consolidated B-24 Liberator had been returned following the end of hostilities. Several Avro Lancasters had undergone rapid conversion, designated as Maritime Reconnaissance Mk3, as a stopgap measure for maritime search and rescue and general reconnaissance duties. However, RAF Coastal Command had diminished to only a third of its size immediately prior to the Second World War. In the emerging climate of the Cold War and the potential requirement to guard the North Atlantic from an anticipated rapid expansion of the Soviet Navy's submarine force, a new aerial platform to perform the anti-submarine mission was required. Work had begun on the requirement for a new maritime patrol aircraft in 1944, at which point there had been an emphasis for long-range platforms for Far East operations. However, with the early end of the war in the Pacific, the requirement was refined considerably. In late 1945, the Air Staff had expressed interest in a conversion of the Avro Lincoln as general reconnaissance and air-sea rescue aircraft. They formalized their requirements for such an aircraft under Air Ministry Specification R5/46. Avro's chief designer Roy Chadwick initially led the effort to build an aircraft to this requirement, designated as the Avro Type 696. The Type 696 was a significant development upon the Lincoln. Elements of the Avro Tudor airliner were also reused in the design. Lincoln and Tudor had been derivatives of the successful wartime Avro Lancaster bomber. Crucially, the new aircraft was to be capable of a 3,000 nautical mile range while carrying up to 6,000 pounds of weapons and equipment. In addition to featuring a large amount of electronic equipment, the Type 696 had a much improved crew environment over other aircraft types to allow them to be more effective during the lengthy mission times anticipated. At one stage during development, the Type 696 was referred to as the Lincoln AS-3 before this was discarded in favor of the Shackleton name. The first test flight of the prototype Shackleton GA-1, serial VW-135, was made on March 9, 1949 from the manufacturer's airfield at Woodford, Cheshire in the hands of Avro's chief test pilot J.H. Jimmy Orrell. The GA-1 was later redesignated Maritime Reconnaissance Mk. The prototype differed from subsequent production Shackletons in a number of areas. It featured a number of turrets and was equipped for air-to-air refueling using the looped line method. These did not feature on production aircraft due to judgments of ineffectiveness or performance difficulties incurred. However, the performance of the prototype had been such that, in addition to the go-ahead for the MR-1's production, a specification for improved variant was issued in December 1949, before the first production Shackleton had even flown. By 1951, the Mk1 had become officially considered as an interim type due to several shortcomings. Further development equals. The Mr. II was an improved version of the Shackleton, featuring numerous refinements that had been proposed for the Mk1. The radar was upgraded to ASV Mk13, and the radome relocated from the aircraft's nose to a ventral position aft of the bomb bay. The radome was retractable and could only be fully extended with the bomb bay doors open. It had improved all-round radar coverage and minimized the risk of bird strikes. Both the nose and tail section were lengthened, the tail plane was redesigned, the undercarriage was strengthened and twin retractable tail wheels were fitted. The dorsal turret was initially retained, but was later removed from all aircraft after delivery. The prototype, VW-126, was modified as an aerodynamic prototype at the end of 1950 and first flew with the Mr. II modification on July 19, 1951. VW-126 was tested at Boscombe Down in August 1951. Particular attention was paid to changes made to improve its ground handling, like the addition of tow brakes and a lockable rudder system. One production Mk1 aircraft was modified on the line at Woodford with the Mk2 changes and first flew on June 17, 1952. After trials were successful, it was decided to complete the last 10 aircraft being built under the Mk1 contract to Mr. II standard and further orders were placed for new aircraft. In order to keep pace with changing submarine threats, the Mk2 force was progressively upgraded, with Phase I, II and III modifications introducing improved radar, weapons and other systems, as well as structural work to increase fatigue life. Production of the Mr. II ended in May 1954. The Type 716 Shackleton Mr. III was another redesign in response to crew feedback and observations. A new tricycle undercarriage was introduced, the fuselage was increased in all main dimensions and had new wings with better ailerons and tip tanks. The weapons capability was also upgraded to include homing torpedoes and Mk101 Lulu nuclear depth bombs. To facilitate crews on 15-hour flights, the sound deadening was improved and a proper galley and sleeping space were included. Due to these upgrades, the takeoff weight of the RAF's Mr. IIIs had risen by over 30,000 pounds and assistance from Armstrong City Viper Mk203 turbojets was needed on takeoff. This extra strain took a toll on the airframe and flight life of the RAF Mr. IIIs was so reduced that they were outlived by the Mr. IIs. Due to the arms embargo against South Africa, the SAAF's Mr. IIIs never received these upgrades but were maintained independently by the SAAF. The Type 719 Shackleton 4, later known as the Mr. IV, was a projected variant intended to meet a Canadian requirement for a long-range patrol aircraft. The Mr. IV would have been a practically new aircraft, sharing only the nose, cockpit, and outer wings with earlier variants. It would have also been powered by the Napier Nomad compound engine. The Shackleton 4 was cancelled in 1955. In 1967, 10 Mr. IIs were modified as training aircraft to replace the T4 in service with the Maritime Operational Training Unit. Known as T2s, the crew rest areas were replaced by additional radar equipment and the original radar fittings removed. Design. The Shackleton was a purpose-built aircraft for the maritime patrol role. However, the legacy of Avro's preceding aircraft is present in many aspects of the overall design. The center section of the Shackleton's wing originates from the Lincoln, while the outer wing and undercarriage were sourced from the Tudor outer wings. At one stage during development, the tail plane had closely resembled the Lincoln's, but were enlarged and changed soon after. An entirely new fuselage was adopted, being wider and deeper to provide a large space in which to accommodate the crew, their equipment, and a large bomb bay. Later variants of the Shackleton were substantially redesigned, adopting a new nosewheel undercarriage, redesigned wings and center section, and a larger fuel capacity for more range. Various armaments and equipment were carried by the Shackleton in order to perform its missions. In ASW operations, the ASV Mk13 radar was the primary detection tool. It could detect a destroyer at a range of 40 nautical miles, a surface submarine at 20 nautical miles, and a submarine's conning tower at 8 nautical miles, although rough seas considerably reduced the radar's effectiveness. Other equipment included droppable sonar buoys, electronic warfare support measures, an auto-helichrous diesel fume detection system and a magnetic anomaly detector system. A special camera bay housed several reconnaissance cameras capable of medium-altitude and nighttime vertical photography, and low-altitude oblique photography. The crew would also perform visual searches using various lookout positions that were provided for this purpose. Weapons carried included up to 9 bombs, 3 homing torpedoes or depth charges. The aircraft also had 2 20mm cannon in a Bristol dorsal turret. An in-flight refueling receptacle could be accommodated, but was not fitted on production aircraft. The Merlin engines were replaced with the larger, more powerful and slower revving Rolls-Royce Griffons with 13 feet diameter contra-rotating propellers. This engine's distinctive noise often caused pilots to develop high tone deafness. Use of the Griffon was necessitated by the Shackleton weighing more than the preceding Lincoln, and suffering from greater drag. The Griffon provided equivalent power to the Merlins but at lower engine speed, which led to greater fuel efficiency in the dense air encountered at a low altitude. The Shackleton would often loiter for several hours at roughly 500 feet or lower when hunting submarines. This also made for less engine stress and hence greater reliability. Using conventional propellers would have needed an increase in propeller diameter to absorb the engine's power and torque. This was not possible due to space limitations imposed by the undercarriage length and engine nacelle positioning. The contra-rotating propellers gave greater blade area within the same propeller diameter. Numerous problems were encountered during the Shackleton's operational service. In practice, the diesel fume detection system was prone to false alarms and thus received little operational use. The engines, hydraulics, and elements of the avionics were known for their unreliability, and the aircraft proved to be fairly maintenance-intensive. The prototype Mr. 3 was lost due to poor stalling characteristics. This was rectified prior to production, although a satisfactory stall warning device was not installed until 1969. The Shackleton is often incorrectly attributed the unfortunate distinction of holding the record for the highest number of aircrew killed in one type in peacetime in the RAF. The true figures suggest rather differently in that some of its contemporaries fared far worse, such as the Gloucester Meteor with over 430 fatal losses of aircrew against the Shackleton's 156. Several programs to support and extend the fatigue life limits of the Shackleton's airframe were required. The fatigue life problems ultimately necessitated the rapid introduction of a whole new maritime patrol aircraft in the form of the Hawker-Siddeley Nimrod, which began being introduced to RAF service in 1969. Operational history Royal Air Force On March 30, 1951, the first Shackleton was delivered to No. 120 Squadron RAF. By the end of 1952 7 squadrons were operating the type. The first operational deployment of the Shackleton occurred in 1955 as a troop transport for British Army movements to Cyprus. Less than a year later, the type's first combat deployment took place during the Suez Crisis, codenamed Operation Musketeer. During the 1960s, the typical Shackleton crew comprised 2 pilots, 2 navigators, a flight engineer, an air electronics officer, and 4 air electronics operators. During this period, equipment upgrades has become routine in order to keep pace with ever more capable submarines. Problems with airframe fatigue were identified, leading to several programs being carried out to strengthen the aircraft and thus extend its viable service life. In 1966, nuclear depth charges were introduced to the Shackleton's arsenal with the aim of countering the Soviets' development of deep-diving submarines. Maritime reconnaissance was a large element of the Shackleton service. This mission was often performed to identify and monitor naval and merchant shipping and to demonstrate sovereignty. During the Indonesia-Euro-Malaysia confrontation in the 1960s, Shackletons monitored the seas for vessels involved in arms smuggling. Similar operations were conducted in Cyprus, and Shackletons operating from bases in Madagascar cooperated with Royal Navy vessels to enforce a United Nations-mandated oil blockade of Rhodesia. The Shackleton would often be used to perform search and rescue missions. At all times one crew was kept on standby somewhere across the UK for this role. The Shackleton had also replaced the Avro Lincoln in the colonial policing mission. Aircraft would often be stationed in the Aden Protectorate and Oman to carry out various support missions, including convoy escorting, supply dropping, photo reconnaissance, communication relaying, and ground attack missions. The Shackleton was also employed in several short-term bombing operations. Other roles included weather reconnaissance and transport duties. In the latter role each Shackleton could carry freight panniers in the bomb bay or up to 16 fully equipped soldiers. In 1969, a jet-powered replacement patrol aircraft, the Hawker Siddeley Nimrod, began to enter RAF service, which was to spell the end for the Shackleton in most roles. While radically differing in external appearance, the Shackleton and the initial version of the Nimrod shared many sensor systems and board equipment. The intention to retire the Shackleton was thwarted by the need to provide AW coverage in the North Sea and Northern Atlantic following the withdrawal of the Fleet Air Arm's Fanny Gannet aircraft used in the AW role in the 1970s. As an interim replacement, the existing ANAPS-20 radar was installed in modified Shackleton Mr. 2s, redesignated the AW-2, as an interim measure from 1972. These were operated by No. 8 SQN, based at RAF Lossiemouth. All 12 AW aircraft were given names from the Magic Roundabout and the Herbst TV series. The intended replacement, the British Aerospace Nimrod AW-3, suffered considerable development difficulties which culminated in the Nimrod AW-3 being cancelled in favour of an off-the-shelf purchasing of the Boeing E-3 Sentry, which allowed the last Shackletons to be retired in 1991. South African Air Force During the Second World War, the importance of securing the sea routes around the Cape of Good Hope had been made apparent, with over 100 vessels being sunk in South African waters by enemy vessels between 1942 and 1945. In the post-war situation, the South African Air Force sought a large and capable platform to perform a maritime patrol role. After evaluating 4 RAF Mr. 2s in 1953, an order was placed for 8 Shackletons as a replacement for the SAAF's aging short Sunderland maritime patrol aircraft. Modifications were required to fulfill South African conditions and requirements, such as the ability to operate over the Indian Ocean. The resulting aircraft was designated as the Shackleton Mr. 3. On August 18, 1957, the first 2 Shackletons were delivered to D.F. Mellon Airport, Cape Town. 2 more followed on October 13, 1957 and the remainder arrived in February 1958. Delivered to the same basic standard as the RAF's Mr. 3s, they were assigned single letter codes between J and Q, and operated by 35 Squadron SAAF. The type typically patrolled the sea lanes around the Cape of Good Hope, often monitoring Soviet vessels traversing between the Indian and Atlantic Oceans. The Shackleton was briefly used in low-level overland patrols along the southern Rhodesian border, but these duties ended following concerns of the disturbance of wildlife. Often, the Shackleton would be called in to perform search and rescue operations in the treacherous waters around the Cape. In March 1971, Shackleton successfully intervened in the SS Wafra oil spill, deliberately sinking the stricken oil tanker with depth charges in order to prevent an ecological disaster. The only operational loss incurred was 1718K, which crashed into the Wemishuk Mountains at night time on August 8, 1963 with the loss of all 13 crew. Due to an embargo imposed by the United Nations over South Africa's policy of apartheid, acquiring components for the Shackleton fleet became increasingly difficult and thus the aircraft's serviceability suffered. The fleet had been modified to Phase 3 standards prior to the implementation of the arms embargo, albeit without the auxiliary Viper engine. 2 of the aircraft were resparred, 1716J in the United Kingdom and 1717O in South Africa by the SAAF, but the lack of engine spares and tyres, together with airframe fatigue, took a gradual toll. By November 1984, the fatigue lives of all but the 2 resparred aircraft had expired and the fleet was retired into storage. Although the joke has been applied to several aircraft, the Shackleton was often described as 100,000 rivets flying in close formation. Accidents and incidents. Variants. Avro 696 Shackleton prototypes equals 3 prototype Type 696s were ordered in May 1947 to meet specification R5/46, VW-126, the first prototype which initially flew on March 9, 1949. VW-131, first flown on September 2, 1949. VW-135, first flown on March 29, 1950. Avro 696 Shackleton Mk1 equals, Shackleton Mr. Mk. 1, the first production model for the RAF with dorsal turret with two 20mm cannon, 29 built. First production aircraft flew on March 28, 1950 and the variant entered service with 120 squadron at RAF Kinloss in March 1951. Shackleton Mr. Mk. 1A, variant powered by 4 Griffon 57 AV-12 piston engines, in service from April 1951, 47 built and all surviving Mr. 1s converted. Shackleton T4, navigation trainer conversion from Mr. 1s between 1956 and 1961, removal of mid-upper turret, addition of radar and radio positions for trainees, 17 conversions. Avro 696 Shackleton Mk2 equals, Shackleton Mr. Mk. 2, version with longer nose and radow move to the ventral position. Lookout position in tail. Dorsal turret and 2 more 20mm cannons in nose. Twin retractable tail wheels. 1 aircraft, WB-833. Originally ordered as a Mr. 1 was built as a Mr. 2 prototype and first flew on June 17, 1952. The last 10 Mr. 1s on the production line were completed as Mr. 2s and orders for 80 new-build aircraft were placed. The last 21 were completed as Mr. 3s and the total number of Mr. 2s built was 69. The first aircraft entered service with 42 Squadron at RAF Street Evell in January 1953. The aircraft were later modified, in parallel with phased modifications to the Mk3, Shackleton Mr. Mk. 2 Phase 1 or Mr. Mk. 2C, as per Mk3 Phase 1. Also received the Sonics plotting table from the Mk3, Shackleton Mr. Mk. 2 Phase 2, as per Mk3 Phase 2. Shackleton Mr. Mk. 2 Phase 3, as per Mk3 Phase 3, except that the Viper engines were not fitted. Shackleton T2, 10 Mr. 2 Phase 3 aircraft were modified in 1967 as T2s at Lancaster to replace the T4s with the Maritime Operational Training Units as radar trainers, with master and slave radar positions for training installed. Shackleton AEW2, in 1971 12 Mr. 2s were converted at Woodford and Bitswell as airborne early warning aircraft. The first AEW-2 flew on September 30, 1971 and the type entered service with 8 Squadron on January 1, 1972. Avro 716 Shackleton Mk3 equals. Shackleton Mr. Mk. 3, Maritime Reconnaissance, anti-shipping aircraft. The tailwheel configuration was replaced by a tricycle undercarriage, addition of a nose entrance hatch, wingtip tanks to increase fuel capacity. To increase crew comfort the inside was soundproofed, better crew seats and rearranged tactical team positions. To make room for some of the internal rearrangement the dorsal turret was not fitted. The first Mr. 3 flew on September 2, 1955, the aircraft had problems with stalling characteristics and crashed on December 7, 1956. The variant entered service with 220 Squadron at RAF Street Evell in August 1957. The RAF ordered 52 aircraft but later following the 156 Defense Review it was reduced to 33 aircraft. An additional aircraft was also built to replace the aircraft lost during stalling trials. An additional 8 aircraft were exported to South Africa. The aircraft underwent several phased modifications. Shackleton Mr. Mk. 3 Phase 1, the Phase 1 update introduced changes mainly to the internal equipment. Shackleton Mk. 3 Phase 2. The Phase 2 update introduced ECM equipment, the distinctive orange harvest spark plug and an improved high-frequency radio. Shackleton Mk. 3 Phase 3. The third of 3 Mr. 3 modification phases including the addition of 2 Armstrong City Viper turbojet engines at the rear of the outboard engine nacelles to be used for assisted takeoff. The wing main spars had to be strengthened due to the additional engines. A new navigation system was also fitted and there was some modification to the internal arrangement, including a shorter crew rest area to give more room for the tactical positions. Projected designs Avro 717 and 719 Shackleton Mk. 4. Project for a re-engined Mr. Mk. 1 using Napier Nomad engines. 2 Nomads were installed in the outer nacelles of a Shackleton prototype to create the only Avro 717 example, but the program was cancelled before the aircraft could be flown. The Avro 719 would have replaced all 4 Griffons with Nomads. Shackleton Mr. Mk. 5. Mr. Mk. 5 was a suggested designation for a Nomad-powered variant of the Mk2. Operators: South Africa, South African Air Force, 35 Squadron SAAF received 8 aircraft. United Kingdom, Royal Aircraft Establishment, purchased a Mr. 3 in 1959. Royal Air Force, No. 8 Squadron RAF, formed in 1972 to operate the AEW-2 at RAF Kinloss, moved to RAF Los Yarmouth in 1973. No. 37 Squadron RAF, 1953-67, converted to the MR2 from the Lancaster GR3 at RAF Luke, moved to RAF Cormaxa in 1957, disbanded in 1967. No. 38 Squadron RAF, 1953-67, converted to the MR2 from the Lancaster GR3 at RAF Luke, moved to RAF Al-Far in 1965, disbanded in 1967. No. 42 Squadron RAF, 1952-71, formed at RAF Street Evil with the MR1A and the MR2, moved to RAF St. Maugan in 1958, converted to the MR3 in 1965-66, converted to the Nimrod MR1 in 1971. No. 120 Squadron RAF, 1951-71, converted to the MR1 from the Lancaster GR3 in 1951 at RAF Kinloss, moved to RAF Aldergrove in 1952, converted to the MR2 in 1953 and the MR3 in 1958, moved to RAF Kinloss in 1959, converted to the Nimrod MR1 in 1970. No. 201 Squadron RAF, 1958-70, renumbered from 220 Squadron in 1958 operating the MR3 at RAF Street Maugan, moved to RAF Kinloss in 1965, converted to Nimrod MR1 in 1970. No. 203 Squadron RAF 1958-71, renumbered from 240 Squadron at RAF Balokelly in 1958 with the MR1A and MR3, converted to the MR2 in 1962 and back to the MR3 in 1966, moved to RAF Luke in 1969, converted to Nimrod MR1 in 1971. No. 204 Squadron RAF, 1954-71, formed at RAF Balokelly with the MR2, also operated the MR1A, and the MR2C, disbanded in April 1971 and reformed at RAF Honington in the same day from the Majunga Detachment Support Unit with the MR2C, detachments to Majunga, Tenga and Mazira, disbanded in 1972. No. 205 Squadron RAF, 1958-71, converted to the MR1 from the Sunderland GR5 at RAF Junji, converted to the MR2C in 1962, disbanded in 1971. No. 206 Squadron RAF, 1952-70, formed at RAF Street Evil with the MR1A, also operated the MR2 from 1953 to 1954, moved to RAF St. Maugan in 1958 and converted to the MR3, moved to RAF Kinloss in 1965, converted to the Nimrod MR1 in 1970. No. 210 Squadron RAF, 1958-71, renumbered from 269 Squadron with the Mr2 at RAF Balokelly, disbanded in 1970, reformed the next day at RAF Sajor, disbanded in November 1971. Number 220 Squadron RAF, 1951-1958, formed at RAF Kinloss with the Mr1A, moved to RAF St. Eville in 1951, also operated the Mr2, moved to RAF St. Maugan in 1956, operated the Mr2 and the Mr3, renumbered 201 Squadron in October 1958. Number 224 Squadron RAF, 1951-66, converted to the Mr1 from the Halifax GR6 at RAF Gibraltar, converted to the Mr2 in 1953, disbanded in 1966. Number 228 Squadron RAF, 1954-59, formed with the Mr2 from elements of 206 Squadron at RAF Street Eville, moved to RAF St. Maugan in 1956, moved back to RAF St. Eville in 1958, disbanded in 1959. Number 240 Squadron RAF, 1952-1958, formed with the Mr1 from elements of 120 Squadron at RAF Aldergrove, moved to RAF St. Eville in 1952 for a few months before moving to RAF Balokelly, operated the Mr2 from 1953 to 1954, renumbered 203 Squadron in 1958. Number 269 Squadron RAF, 1952-58, formed with the Mr1 from elements of 224 Squadron at RAF Gibraltar, moved to RAF Balokelly in 1952, also operated the Mr2, also operated the Mr2 in 1958 as they were renumbered 210 Squadron. Number 236 Operational Conversion Unit, RAF, 1951-56, received the first Mr. 1s in 1951 at RAF Kinloss, redesignated the Maritime Operational Training Unit in 1956. Maritime Operational Training Unit, RAF, redesignated from 236 OCU in 1956 with 15 Mr. 1s, the Mr. 1s were slowly replaced by T4s, moved to RAF St. Maugan in 1965, the last T4 was replaced by a T2 in 1968. Air-Sea Warfare Development Unit, RAF, 1951-60 at RAF Balokelly. Joint Anti-Submarine School, operated the Mr. 2 between 1954 and 1957 at RAF Balokelly. Survivors. Airworthy SAAF 1722P, commonly known as Pelican 22 feet, is the only remaining airworthy Shackleton Mk3. The aircraft is owned and operated by the South African Air Force Museum based at AFB Esterpoort. It was one of 8 Shackletons operated by the South African Air Force from 1957 to 1984. Airworthy but has been grounded for safety and preservation reasons as well as a lack of qualified crew. Under restoration Mr. 2W963. In the care of the Shackleton Preservation Trust, under long-term restoration to flight. Aircraft is capable of taxiing, though does so infrequently. Based at Coventry Airport, England. Static display South Africa, SAAF 1721 on display at the South African Air Force Museum in Swartkop. SAAF 1723 on display at Vic's Viking Garage, next to the Golden Highway in Merridale, Johannesburg. United Kingdom, Mr. 1 VP293 at Coventry Airport, England. Mr. 1 WG511 at Flambards Theme Park. Mr. 2 CWL795 on display at RAF Street Maugan, England. AEW2W960 on display at the Museum of Science and Industry in Manchester, England. Mr. 3W971 at West Walton. Mr. 3W977 on display at the Newark Air Museum, England. Mr. 3W982 on display at the Gatwick Aviation Museum, England. Engines can be run on this airframe. Mr. 3W985 privately owned at Long Marston, England. Mr. 3XF708 on display at the Imperial War Museum, Dewford, England. United States, AEW-2WL790 on display at the Pima Air and Space Museum, Tucson, Arizona, USA. Other airframes. SAAF 1716 was restored to flight in 1994, but later that year, while on its way to the UK, it crash-landed in the Sahara Desert after a double-engine failure. The crash did not result in any casualties, but the aircraft was abandoned in the desert. SAAF 1717 used to be on display at the Transport Museum in Stonja. Was broken down in 2009. SAAF 1720 used to be on static display at AFB Istaplort. It was dismantled as scrap due to corrosion in March 2013. AEW-2WL747 standing abandoned at the western end of runway 11/29 at Paphos Airport, Cyprus. AEW-2WL757 standing abandoned at the western end of runway 11/29 at Paphos International Airport, Cyprus. T2W967 abandoned at Paphos Airport, Nicosia, Cyprus. Mr. 3XF700 abandoned at Nicosia, Cyprus. Mr. 2WL756 preserved until May 2014 at Carnarvon Airworld Museum, UK. Current whereabouts unknown. Specifications. Data from Flight International, Jones, General Characteristics, Crew, 10, Length, 87 feet 4 inches, Wingspan, 120 feet, Height, 17 feet 6 in, Wing Area, 1,421 FTA², Airfoil, Modified NACA 23018 at root, NACA 23012 at wingtip, Empty weight, 51,400 pounds, max takeoff weight, 86,000 pounds, 39,000 kilograms, fuel capacity, 4,258 imperial gallons, power plant, 4A, Rolls-Royce Griffon 57 liquid-cooled V12 engine, 1,960 horsepower. Each, propellers, contra-rotating propeller, 2 per engine, propeller diameter, 13 feet. Performance, maximum speed, 260 kn, range, 1,915 mi, endurance, 14.6 hours, service ceiling, 20,200 feet, max. Wing loading, 61 pounds FTA², minimum power mass, 91 horsepower per pound, armament, guns, 2A, 20 mm Hispano Mark V cannon in the nose, bombs, 10,000 pounds of bombs, torpedoes, mines, or conventional or nuclear depth charges, such as the Mk101 Lulu. See also, related development, Avro Lancaster, Avro Lincoln, aircraft of comparable role, configuration and era, Breguet Atlantic, Canada CL-28, Lockheed P-2 Neptune, Lockheed P-3 Orion, Tupolev Tu-95, Hawker Siddeley Nimrod, related lists, list of aircraft of the RAF, list of aircraft of the South African Air Force, list of accidents and incidents involving the Avro Shackleton. References. Notes citations bibliography Further reading, Callaway, Tim. Avro Shackleton, The Grey Lady. Aviation Classics. Lincolnshire, UK, Aviation Classics. Retrieved October 25, 2014. External links, The Shackleton Association, aircraft.co.za Avro Shackleton, website of Shackleton W963, Shackletons, Thunder Across the Bay.